Yeah, thank you very much for having me, and thank you for the nice introduction. Yeah, let's see what you make of what I have prepared for today. I'm hoping you're seeing just a slide, right? Yes, I'm sharing the right screen. Yeah. So this is going to be a bit of a sort of meta level talk in a way. So I'm not going to talk so much about sort of the daily business in my research group, but I kind of wanted to use the opportunity to reflect on larger points. Now I realize that maybe for this audience, I'm maybe talking about stuff that you know better than me potentially, in which case I'm looking forward for some questions that are really comments at the end, perhaps. But let's see about this. Okay. So what I kind of like to do in talks is to start with the conclusions. For one, should you happen to fall asleep sometime during the talk, then at least you get a little bit of an idea of what the intended message was, but also because it kind of tells us what we will be working towards here. So the first bit is the claim that user-facing NLP technologies often appear to be not just language processors, but language users. And NLP here, of course, stands for natural language processing. It's kind of the modern name for my field, which used to be called computational linguistics, but now most practitioners would probably identify as NLP, natural language processing researchers. So the use of these technologies kind of implies that they are not just processors, but rather language users. So I'm making an opposition here between these two terms. More specifically, what I'm claiming here is that the way these technologies use language is conceptually different from how people use language. And also from how people assume that these technologies use language. So there's a mismatch here, and this is potential for conflict. And this is something we in the field need to think about, is my claim here. And I will also point out some ways that we've thought of to potentially address this mismatch. I will come to this at the end. So the structure of the talk basically reflects the work we have to do to establish these claims, establish these conclusions. I will start with a bit on background. I'm going to tell you a little bit about myself, just so you know from where I'm coming, from where I'm speaking. And then I kind of zoom out and talk a little bit about the wider situation in AI, in NLP, in artificial intelligence, as it pertains to language, because there's an interesting contrast to be made there. And I will set up this opposition between language processing and language user, at least this distinction a little bit more clearly. And with this background in hand, I will talk a little bit about sort of common sense or agreeable model of how human meaning-making functions, and then we'll look into how computer speech can be meaningful, and then address these mitigations perhaps at the end. Okay, so about me, and thankfully you've mentioned most of the things, so I'll be quick here. My first degree is in computational linguistics, philosophy, and computer science. My PhD from Edinburgh in Scotland was on applying methods from philosophical logic or formal logic, but also computational model methods to the pragmatics of dialogue. And there were a couple of postdocs afterwards, but basically since then at various positions, I've retained my interest in working on dialogue. And specifically, something we've looked into a lot is referential interaction, so the interactive process of establishing shared understanding. Or at least this is the area that produces the nicest pictures. So what we have here is, in the middle is a little robot that we built. This robot can grab stuff. So you instruct it to take something, and then it moves there and takes it. And we've looked into the whole interactive process, not just resolving what you say into which piece should be picked up, but also how the speed with which you move there and the directness with which you move there is a communicative signal as well, or can be a communicative signal as well. So that's the thing in the middle. The thing on the right is a robot that we hacked to actually have eyes so that we can study how gaze influences referential behavior by being able to simulate gaze on this little robot. And what you see on the left is it's kind of like a scan path. This is actually a mouse, the path of the mouse, but it's kind of like an eye tracking scan path while people listen to this, now read this, referring expression here. I'm telling you this because my view on language and language systems comes from looking at this, from looking at how people interact, from looking at spoken language. And that's relevant because this is a little bit at odds with how NLP looks at language, with how the mainstream of natural language processing looks at language. More on this in one slide, but first sort of the general situation. If you look at the situation that we're in AI in general, or NLP in particular, at the moment, especially if you're not from the field, if you're looking a little bit from the outside, you could be forgiven for having a very conflicting belief about this state. So you might believe that general artificial intelligence, so AI that can do anything, is already here. But at the same time, you may believe, oh, it's not actually here. So here's something that you certainly will have heard about. This is something that happened this summer. This Google engineer who thought that the chatbot that he was tasked to red team to talk to and evaluate for safety issues, he thought that this has come to life or is sentient. And this is a little bit older here. And it says something like Google says it's closing in on human level artificial intelligence. Okay, so it seems like, wow, we have AIs as not a name of a field, but as the name of an entity. It's already there. At the same time, we have something like this, right? This is a very recent development. Amazon Alexa appears to be a colossal failure, on pace to lose $10 billion this year. And that's a little bit surprising, right? You would think that if AI was there, if general AI was there, then having intelligent agents that sit in a little sphere and can answer all your questions would be a very useful thing to have, right? But very clearly they're not there. So what's going on here? Is it here or is it not here? For a specialized audience, I frame this slightly differently as a sort of puzzle that we have to respond to. And more technically, the puzzle is that the field is struggling a little bit to come up with evaluation corpora on which the current models don't perform very well, right? So if your model that you're evaluating gets 100 of 100 points on your evaluation corpus, then you don't know if the second model you're building is getting better because you can't get better than the best mark, right? And we have corpora like the super glue corpus, where GLUE stands for General Language Understanding Evaluation. So it's quite an ambitious name, right? We have corpora, and they consist of what looks like pretty difficult text exercises, right? You don't have to read this in detail, but there are tasks in there, language tasks in there that kind of look like this. You have a long chunk of text, and then you have a question, and the idea is that this question is answerable by having read the text, right? So would the mass of a baseball affect how much force you have to use to pick it up? And the answer here is yes. Okay, and this is built as reading comprehension, right? And this is probably not the state of the art anymore. This was a couple of months that I looked this up, that I looked this up on a leaderboard, but the leading model at that time got 91.2 points on the overall corpus, not just on this kind of task, but lots of tasks like this. So that's a pretty high score, right? And this wasn't a super special model. This was just a very well-tuned variant of an idea that is around. right? So that's a pretty high score. That's pretty amazing to be able to do these kinds of things, right? So my daughter, who's learning English at school, if she were able to reach 91% on this task, I would be quite pleased. I would actually probably be quite pleased if I were to reach 91% on these kinds of tasks. So that looks great, right? At the same time, and I'm sorry for putting Alexa on the spot here, but that's kind of more my area. At the same time, we have Alexa. Some of us have these things in our homes, and this is anecdotal evidence, sure, but this is something that happened to me. So I ask, are the lights upstairs switched off? And then the thing says, you don't have a group called the lights upstairs. There's a group upstairs lights and a group kitchen. It's like, okay, that is not entirely helpful, right? It's annoying, but not a big problem, but it doesn't look super intelligent, you might agree, right? Something you may have heard about this, it just went through the press, I think this was last year, something that's potentially a little bit more troubling. So someone, apparently a young child, a 10-year-old child, said, tell me a challenge to do to Alexa. And Alexa came back with, here's something I found on the web. According to blah, 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 the challenge is simple: plug in a phone charger about halfway into a wall outlet, then touch a penny to the exposed prongs. That's not a great idea. Okay, you don't need to know a lot about physics to know that this is not a great advice to give to anyone, really, right? And actually, if you follow up, it's kind of interesting and related to my main topic today. It's kind of interesting that they kind of try to dissociate Alexa. Amazon is trying to dissociate themselves from responsibility for this by pointing to this website, right? But still, it's not working. We will see later why this is not quite working. But even that is a fail. If you look at this original website, you find that the text there continues, right? The text has an obviously do not attempt this at home warning there, right? So there's a clear failure of text understanding here, or at least of pragmatics understanding is what I'm claiming here, right? Of the consequences of saying something. And yeah, so this is the background. So AI technologies, NLP technologies are doing great stuff. Or at least it appears so in the lab, but if you put them in people's homes, not so much. So, and my hunch, at least my claim, is something that I've been developing for a while, is this, that one part of the problem here is there's a conceptual difference between language processing and language use. So language processing, NLP, conceptualize the task as finding a mapping between an input and an output. And for technical reasons, this may or may not tell you something. For technical reasons, we want this to be IID, the individual instances. So independent and individual and independently distributed. So basically, we want this to be context-free, right? The individual tasks instances have nothing to do with other task instances. Want them to be functional, so the same input has to lead to the same output at all times. We think about this as atemporal things, so it doesn't matter, somewhat ironically, given that the field is called natural language processing, but the actual processing time, the actual act of processing, doesn't figure into this. It doesn't matter how long the processing takes, we care about the input and output relation. And we want those tasks to be self-contained and to refer to as little context outside of the individual instance as possible. And my claim here would be that language use is something, this works differently. Language use is highly contextual and situated. Language use is interactive, and language use is always grounded. So not just in those instances where you have images involved, it's always grounded in human practices, which aren't accounted for in this way of setting things up. The consequence is that NLP works best for tasks where the input has semantic control over the output, kind of like a transduction task, right? So things that are actually working amazingly well these days are translation of basic texts, right? Of texts like instruction manuals, which are written to be self-contained. But the more you move into texts that are embedded in a wider context, like literary text, the less well it actually works, right? It works well for summarization, for some image captioning tasks, and for reading comprehension, where reading comprehension is set up in the way that I showed you from the superglue instance, right? Where reading comprehension really means there's the text is there and the question can be answered by looking at this very text, not at some textbook that you read last week, but rather the text that is there. And the more the use case becomes like language use, the less well do things work. For example, question answering doesn't work so well, and task-oriented dialogue doesn't work so well. I won't go fully into this distinction that I'm making here. This is a different talk, but I needed this to set things up. But if you're interested in this, I have some papers on this. And yeah, I put a bibliography on the PDF of the slides at least. Okay, so coming back to the conclusions. So that was the background to this. And what I now need to do is to establish these conclusions, is to talk a little bit about how people use language and how that is different from how these models use language. If that is even the right way to call it. And it will come out that I think it's not the right way to call it. The models aren't actually using language. Okay. So with this, I give you sort of a minimal model of meaning making, or is clearly maximizing the number of M's I could put in here. So my minimal model of meaning making is the following. And this is really just pragmatics 101, if you know this. I don't quite know what your background is, so bear with me, but I may be telling you things that are very familiar to you. Okay, so let's imagine this is you, and you're standing next to a wall, okay, and you observe some smoke. Yeah, so you see smoke coming from behind the wall, but you only need it because of the wall. You only see the smoke, and you're forming the belief there's a fire. Quite reasonably so, that this is a belief you form. And the question now is, how are you justified in forming this belief? And to set this up a little bit, why am I telling you this? Because I later want to think about how the same thing works if a computer tells you something. So how are you justified in forming beliefs from what a computer tells you, right? But now no computer involved, there's just smoke, and you form the belief, oh, there's a fire. Why? Because you know that smoke means fire, right? You have the experience that tells you, okay, so there's a causal relationship between fire and smoke. And technically what you're doing here is an abduction. You reason back to the best explanation, right? And this allows you to have a shorthand like smoke means fire. And of course, the kind of meanings we are dealing here with is natural meaning, what Herbert Paul Grice, the philosopher of language, in his seminal 1957 paper meaning called natural meaning. Okay, and if you know this stuff, then you know where this is going. Let's exchange the situation. Situation is now different. You don't observe any smoke for some reason, but you hear someone saying there's a fire. Okay. So what justifies you in still forming the belief there's a fire? How do you get from this acoustic event to the belief you're having? And clearly, it's not the fire that's talking, right? So the fire is not directly causing the utterance there's a fire. That would be very weird. So you quite reasonably, hopefully, and that's why I'm calling this sort of a common sense model, you assume that there's a human who produced this utterance, and there's certain things that are true about this human who produced this utterance. You think that this human had a belief, a fire belief. The human thought there is fire. And that's why they said there's a fire. And the chain goes on, and you think, principle of charity and all, you assume your default assumption would be that they have this fire belief on account of there being a fire. There's a certain state of affairs that is the case, and the state of affairs is related to the belief that they're having, and the belief is related to them making this utterance. Okay, so that's fairly uncontroversial. But by the way, if you have questions at any point, just barge in, or we can take questions later. But okay, and this is what Grice called non-natural meaning. Okay, so there's a different. So there's a fire means there's a fire works differently from smoke means fire, right? So that has to be something, at least it has to be a little bit more complicated than this. So let's look at this in a little bit more detail. And let's look at the arrows here in a little bit more detail in particular, because this is what I will later be saying. This is what's different, what is different in a computer, in the way a computer might be connected to a state of affairs. Okay. All right. So one way of saying this, how the belief is connected to the expression. Well, I use the word, we call these things expressions, and this kind of indicates that there is a relation. They are expressing something. So the belief is expressed by this. But you probably want there to be more going on. And in a Gricean analysis, at least, you would have some sort of communicative intention here. And the way to express it would be that the utterance, there's a fire, is meant to figure in the recognition of the intention to convey this belief, right? So the speaker had the intention that you recognize that they have this belief, and they had the intention that you recognize this belief through the utterance. So they don't just want you to recognize something, but they want this utterance to be the thing that helps you recognize this intention in them, this belief in them. Okay, so that's this connection. And now I'm changing vocabulary a little bit. So the state of affairs of there being a fire entitles the speaker here to have this fire belief, right? Or the other way, the arrow going the other way around. The belief is justified by the state of affairs. Okay. And I will come back to this, but the vocabulary that I'm using here now is suddenly normative vocabulary. I'm talking about entitlements here, and that's going to be an important component of things going forward. But this is not all. You will probably have more assumptions about the speaker as well. You will also think that, okay, so if they believe that there's a fire, they will have other beliefs as well, which are naturally entailed by a fire belief. They will probably also believe that there's heat, and they are, by default at least, would believe that that there's danger. So there's a structured set of beliefs that you are assuming. I should pause at this point and say that this is sort of a rational reconstruction. I'm not saying that this is the process by which you arrive at your belief. It's quite possible, and this is not a cognitive theory at this point. This is a rational reconstruction, right? You may have shortcuts that get you from hearing there's a fire to thinking there's a fire, right? But the way we can point out that this analysis is not completely off is because all these points can separately fail, right? So you can, it is quite possible if someone says there's a fire that there is no fire, right? And the way they would defend themselves is by saying, oh, but I thought there was a fire. I believed there was I said this because I believed there was a fire, right? Or you can find out about someone that they believe there's a fire, but they don't believe that there's heat. And then you would ask, what's going on? How is this possible? This is not my concept of fire, right? So these things can figure, right? And we actually have quite quite sophisticated ways of discussing this, right? Let's assume someone, that's the old example, someone in a theater shouts, "There's a fire," right? Which is potentially endangering to others, because then they will be warned and want to run away. And it turns out there was no fire. Then you can discuss, okay, how justified were they in believing this, right? Maybe there was just a picture of a fire, but were they justified in believing that there's a real fire just by seeing a picture, right? So we can do all these things. We can have discussions about these things. And in disagreements, these justifications must be made explicit. And we probably would assume that someone has a good basis for forming a belief, right? Someone had, the person forming this fire belief should have had their eyes open, for example, right? Dreaming about something is not a good basis in our culture for forming beliefs. So you can attack, you can discuss all these things. And my point here is that there are normative standards about this, right? So the point is, these are normative relations, there are standards for doing things right. And there are things that entitle you to do certain things. So there being a fire entitles you to have a belief that there is a fire, and having this belief entitles you to saying this. But the other way around, it also commits you to certain things, right? It commits you to believing this. Having said this commits you to certain things. And if those things turn out to be not the case, then you have a problem, and we need to talk about this. Okay? So the mechanism that I want to work with here is the following. So if the speaker is doing speaking right, then they will have this belief. All things being equal, right? In different contexts, you can say there's a fire without needing to have this belief, but in a sort of in a null context. If you're doing speaking right, then you should have this belief. And if you are having beliefs right, then you should have other beliefs as well. You ought to have other beliefs as well. And you ought to have a good basis for having this belief. Now, a crucial point is that it's always possible to disagree about what doing things right is, right? That's the beauty of this. It has to be possible to disagree about this. These are not natural laws, these are norms, right? And it's also possible to disagree about whether the speaker was doing the right thing, even if you agree on what doing the right thing is. Okay? Okay, this may sound very sort of abstract, and what does this have to do with computers? And we're not quite there, but we're almost there. What I've talked about here is how I think that people use language and assume that language is used, and also probably assume that computers use language, but computers actually do not use language in this way. They're not connected to what they're talking about in quite the same way. Okay, so now I have to talk about how machines use language and how that is different. So the question here now is, where am I there? The question now is, how is computer speech meaningful? And note that I'm not saying that computer speech and the language that comes out of these kinds of models is meaningless. There are people out there actually who kind of seem to be claiming something like this, but I think that doesn't quite cut it. We have to explain how the meaning making there works differently and how this can cause a problem. And I take a short excursus into how large language models work, because these are sort of the paradigmatic AI models these days. Oh yeah, okay, but first, again, setting this up a little bit. So the question is, how do computers use language? What can we compare this to? What is the analogy here? And I've already said it's not quite the same way as these connections work in humans. So what is it like? Is it like how signs use language? Like you find a sign affixed to a fence saying "Beware of dog." So how does the sign use language? Obviously, the sign doesn't use language, right? The person who put the sign there uses language. So this is just a different way of presenting the language to you. But the reader of this sign will go through the same mechanisms. They assume that there was someone who intended to convey something by putting up this sign, right? So that's not a super interesting model. Is it maybe like a mechanized sign? So you could imagine there's a machine that has a photosensor, right, that measures the wavelength of light that falls onto the photosensor, and there's a little needle affixed to this machine, and depending on the wavelength, the needle goes to different places. So does it make sense to say that this machine here uses language in some way? Probably not, right? This is just kind of a mechanized sign. Someone, the designer of this machine, put the causal relations in place that lead to this association of state of affairs to language, right? So is it maybe like a parrot? And if you know the field, you know that this has figured in a somewhat famous paper from, it's crazy, it's only last year, I think. But anyway, this has figured in a somewhat important paper, but parrots have fascinated people who are thinking about language since forever, because they are natural systems, obviously, right? It's not a parrot is not a machine unless you're Descartes and have strange ideas about non-rational beings. It's a natural system, and you can imagine that you train a parrot to say the human word, or at least make the human noises that correspond to red, if it sees something red, right? So you can set this parrot up to be a system that does this. So is language used by computers kind of like the parrot? Maybe it's trained, but certain things are lacking, or, and this would be sort of the most insulting to the poor computer, is kind of like an Ouija board, right? You know, these games, or maybe like a die that you throw with letters on. Is it completely random? Is it by chance that it looks like language, and it's only us who produce the meaning for it? So somewhere in this spectrum, we can try to locate the meaning making, the meaning production by computers. Okay. Okay, so of course, language production by computers can be like a sign, right? So we think about this, a lot of the language that the computer produces to us works kind of like this, like the beware of dog sign, right? So if something like this were to happen now, right? If a computer throws up, this is not real, this is just an example, but if the computer throws up a warning like this, right? This kind of works like a mechanized sign. The programmer has set up, if they've done their job well, the programmer has set up a causal relationship between an internal state of the computer and this thing as a whole, right? And this means, hopefully, what you think it means by being causally connected, by being necessarily connected to the event. But this is kind of boring, right? I mean, this is kind of like, this is how print statements produce language, and they mean something because the programmer behind the print statement meant something. But that's not AI. So let's look into AI a little bit. And this is the little excursus here. So what people often associate with AI when it comes to language is the particular setup that is called language model these days. Again, I don't know how much you know about this. So again, bear with me. It's just 2 slides on this. So anyway, so language model is a bit of an unfortunate naming. And the naming can be explained by where it comes from. So I think Fred Jelinek established this term, a Czech-American language technology researcher who did many seminal works, first at IBM, later at Johns Hopkins University, mostly in speech recognition and statistical methods to speech recognition. And he was building on work by Claude Shannon when he coined this. And crucially, language model makes sense in the context of there also being an acoustic model. So in a, why does it say? Oh, okay, so it's not part of speech recognition. It's a part of a speech recognition system. Okay, so as part of a system that recognizes spoken speech, you have an acoustic model. I'm simplifying things a little bit here. You have an acoustic model, and this acoustic model basically tells you which sequence of phonemes was uttered, or what the most likely interpretation as a sequence of phonemes is of the incoming audio. And then needs to be a second part, a language model that tells you what the most likely sequence of words is that can be built out of the sequence of phonemes. Okay, and this is the thing that you needed to have both of these things. This is kind of what caused fun mishearings, that something like recognized speech can be recognized by this system as what I have here first, recognized speech, or as recognized speech, which sounds the same. And I think at least that's probably an apocryphal story, but the early speech recognizers would be more likely to have recognized this here, right? Because that's the more likely sequence according to the language model. So basically, a language model is a model of the probability of sequences of words. Or equivalently, it's a model of how a given sequence of words, or generalizing of tokens of a given sequence might be continued. So it can tell you what are more likely and less likely continuations of the sequence. So language model is a fairly large name for this very simple idea. Okay. Okay, and what about these large language models that we have now, where the importance really is that they are very large? Well, they're basically taking the same idea. They're taking this idea of language modeling, of distinguishing between likely and less likely sequences. They don't do this by continuation. They are trained on predicting missing bits also within a sequence. So the input might be the quick brown app jumped over, blah, blah, blah. And then the task is to predict the word that is most likely there. And two developments are important here. One development is that the models with which this can be done have become much more powerful. They have much higher capacity to learn stuff. And also still in this part, we can train them over for much longer times. And the other important development here is that you can take any text and turn it into this task, because in any given text you can mask out certain parts and then just ask the model to train it on the task of predicting the thing that was actually there. Right, so you don't need to do any annotation, and you can take the whole internet as a text and train your models on this. And somewhat amazingly, I wouldn't have predicted this, but somewhat amazingly, these models to do this job well, if you train them for a long time using the self-supervision regime, to be good at this job, and they become good at this job, they need to develop all kinds of specialized routines within them. They don't just look anymore at text probability sequences. That's not a good way of thinking it. They develop all kinds of specialized routines. For example, they can do something that looks a bit like doing maths, right? If they have to do something like this, the square root of 25 is, or the square root of is this, right? So within the weights of the network, they develop subroutines. That's not quite the right way of talking about it, but it's kind of okay to think about this. They develop subroutines for doing math, and that generalize a little bit. Well, they also develop subroutines that kind of look like common sense, right? So she cried because her team, well, common sense would tell you that you cry because your team loses. I put this example there before certain events, recent events. Anyway, what also turned out is that sort of once people hit on this scheme, it turned out that you can do a lot. You don't just have to go for text. You can also take an image and cut it into little pieces and put this on the input side as well. And suddenly your language kind of learns, your model, your language model kind of learns to ground into images as well. So that's quite amazing. The question now is why I'm setting all this up is the question for the last 5 minutes. It's going to be a little bit tough, but let's see. Is what's going on in these models, is this the right kind of connection between something and the output, between state of affairs and the output? Okay. Okay, let's see how I'm going to do this. I think I'm just going to do this one and then skip over the next one. Okay, so let's do this. And this is sort of a little case study. It's like a thought experiment meant to sort of be an intuition pump here. So the question is that I'm setting up here is at what point does the connection between the input, the stimulus, so to speak, turn from a causal connection to something else, maybe, right? And the little story is, let's assume you move to the suburbs, you have a nice house now, a nice garden, but someone is messing with your outdoor furniture when you're not looking, and you want to know what's going on. This is the little story. Yeah, right. Okay. So how can you find out what's going on? And what I'm setting up here is I want you to think about under which conditions you're justified to have a belief based on being told something, right? So just like the smoke means fire, or there's a fire justifies you having a belief there's a fire, you now want to know something about something going on. So the first attempt that you do is you buy one of those little light barrier alarms, right? So if a light beam is interrupted, it plays a sound, okay? That doesn't quite help you while you're at work, but it will help you while you're not looking, and then you can run there and see what's going on, right? And of course, the connection here is just like with the smoke, right? So the sounding of the sound means in a natural way there's activity outside. The barrier has been broken, okay? And should you find out that that this little thing plays, sometimes it plays sound, sometimes it doesn't, and you can't quite see what's going on there, if it does this randomly, well, then you just return the damn thing, right? So you bought a product that is broken, and if it's still within warranty, you return it and say, this is bad. This is not doing what it's supposed to be doing. Okay, but instead of giving you the same, they upgrade you. The company upgrades you. They give you the new model, and the new model has, I don't know, it has a little SIM card in it, and it actually sends you a short message, a text message, right, an SMS. If the light beam is interrupted, you get a text with the word alarm. Now, is this language use? Suddenly, is this more like language use? Probably not, right? The connection is still very much a causal connection, right? It's just a little bit more complicated, but this isn't real language use. This isn't any, the language doesn't add any value. It could be anything apart from the word alarm. Just the fact that you're getting a text message is what gives you the information, what justifies you in having the belief that there's something going on. And again, if these things should start to text you randomly, then it's just broken. You return it. Okay, I'm slowly working my way here towards making sense here, hopefully. Now you upgrade because you see in the shop, you see a box that says AI on it, and you, ooh, I want AI. So what you have now is a little camera and an AI system, a classifier, and this can do three things. It can send you an SMS if it has detected a large animal, can send you an SMS if it has detected a human, or it doesn't do anything if it has detected anything else. So my question now is, how does now large animal mean there's a large animal on the patio? Okay, so is this meaning N? Is this natural meaning? Is there causal relationship? Or is there a normative relationship, or what's of the same complexity as the relationship that I built up for there's a fire connecting to the state of affairs? Okay. So I don't know what your intuitions are. My intuitions are like, it's not quite causal anymore, right? Because the intermediate there is this classifier that has been trained on some data set that is unknown to you. And again, we can sort of try to push this further by developing intuitions. So let's assume that you look out, you see that there's a raven who is actually moving your furniture around, bad raven, but this thing didn't fire, right? So who do you complain to? What are your grounds for complaining now? The company says to you, well, our annotators, they go back to the data system, to the training set, and they go, oh, no, our annotators all think a raven is not a large animal. They have annotated images of ravens, and they have not annotated them as large animals, so you're wrong. And you're probably a little bit unsatisfied there. So you're still not quite sure how this is telling you useful information. Okay, I'll do this. So we can continue with this game a little bit. An upgrade of this system. It doesn't just produce labels; it produces full sentences. And if you know the field, then you know that this is called an image captioning system, right? But here, and let's very hypothetically assume that the view onto your patio happens to be the Rialto Bridge. You live in a very privileged part of this town, apparently. So something we know about these models is they are liable to produce quite different things given different conditions, right? Depending on what was in their training data. So at different times of the day, they might be producing something that goes from a group of people walking down the street to a train that is sitting on the tracks, right? This would be very bizarre for a person to do, looking at the same scene all the time, right? Because these are dramatically different beliefs, and you shouldn't be having these beliefs without having a good reason for why things change so dramatically. But these systems being trained on individual instances of connecting an image to a description, they are not set up to have a notion of being connected, of being the same system over time, right? So this is a very different kind of language using system than a human would be. Okay, and then you might come to the idea that, well, it doesn't make full sense in the story anymore. You wouldn't want to chat with your alarm, but there are systems out there that do this, so that turn this into an interactive task, right? And again, this is super unfair. If you know this field, what I've done here, this is a demo of a visual dialogue system. That's super unfair. They're not trained to do this kind of stuff here, right? So I asked, are there birds? It says I don't see any. I ask, are there pigeons? And it says yes. So if it makes even makes sense to talk about the beliefs of the system, then there are very different beliefs than what we have. If we have a pigeon belief, then we also have a bird belief, right? But these systems are not trained to do this kind of stuff. But that's kind of my point here, that they're not trained to do this, right? So the observation that I wanted to make here is that these models do not behave like you would expect from someone making an assertion, right? So what they're doing here very much looks like the speech act of making an assertion. The linguistic form is there. right? A declarative sentence. But a lot of other things are not there, and they're not even on the radar of these systems, right? They're not trained for this, they're not evaluated for this. But there's no constancy of belief, there's no network of beliefs, there's no justifiability, and crucially, there's no commitment, right? So the model doesn't care about what it says, and it's not embarrassed by being wrong, right? Okay, so I'm gonna skip over search. And I have another case study here, but we can come back to this in question time, maybe if you're interested in this. But this basically develops the same thought for search systems. You want, if you ask a question to a search system, you want the answer to be connected in a justifiable way to the state of affairs, right? So this kind of question, typically what connects you to the person who commits to the actual answer is very long, right? It might be that you're looking up in a lexicon, and your interest stops there because the entity offering the lexicon is committed to the truth of this. But that's not to say that you don't want this chain of commitment to be there. And the claim here is that what people have started using language models as search engines, it's not a very great idea. Okay, because this breaks this connection. Okay, so sort of moving towards the final stretches here. What I was claiming here, and sort of an argument that I sketched, I'm fully aware that this is not the full argument, but this is at least sort of the outlines of the argument. The argument is that the way that these models make a connection to what they're talking about is different from what you assume and what I will argue in a second, rightfully and justifiably, and you should think that people are doing. Yeah, there's a difference here. So what these models are okay-ish is in making a straight connection between a state of affairs and an utterance. That's what they're trained on. That's what they are evaluated on. A connection that goes only in this one direction, right? But what's missing is all the framework around this. And what's missing is the ability to justify, to treat the state of affairs as a justification for your internal state, and to make this discussable, right? And what's also missing is the ability to be committed to the truth of what you're saying, because it's just a computer, right? Okay, all right. So this was at least the outlines for my for this claim here, and now some possible ways to address this mismatch. What is the way forward? And I don't have all the answers here. I probably don't even have very many answers, but I think this is something that requires some thinking, which potentially maybe what you guys are doing. I want to hear more about this, but anyway, so the way forward. There's a road better not taken, which would be to erode the norms of language use. And I worry a little bit that this is the road we are on. And this is certainly the road that certain actors are interested in taking. So a statement like, no one is responsible for the output, use at your own risk. That is, I'm not saying that this is impossible. I think we can talk ourselves into treating things like this, but I don't think this would be a good way of using these technologies, right? I have a couple of slides at the end. Yeah, well, okay. Another similarly not useful part of this branch of the road is to say, well, the AI is responsible for what it says. And this is what leads you to all this weird AI safety and AI alignment research that happens if in young age you've read too much science fiction and then suddenly think this is real, right? But if you say that the AI is responsible for what it says, it's very likely that someone is just trying to get out of product liability. Okay. All right. So what I think is the better branch of this road is that in any case, the provider of the model needs to pick up the commitments of the language use, right? And that makes it very much in the interest of the provider of this language using computer to make the connections more causal, to make them more understandable for themselves, right? Because that limits their exposure to problems, right? But this is actually what stops, and I think that's actually a good thing, what stops the adoption of deep learning technologies in the real world. So if you talk to people building dialogue systems, they're very wary of using deep learning based systems because they want guarantees about what these things say, right? They quite well understand that they will be held liable, right? If IKEA comes out with a chat support system that can be tricked into spewing out racist language, they know they would have a problem, right? And again, I think the solution would not be to say, oh, well, it's just a model. So sticking with these kinds of approaches and saying, yeah, but no one has responsibility here is not the right way. The right way is to better understand and to give more guarantees about how what the output might be. And it very well might entail giving up on open domain, giving up on general AI stuff, because you can't give these kinds of guarantees in open domain systems. Give up for now, for the foreseeable future, on what I'm calling autonomous speaking here in an analogy to autonomous driving, right? Or you could model what I've called in another paper, what I called norm participation. You could model this as an interactive skill, the skill of giving and asking for reasons, or somewhat grandiose, I've called here dialectic AI. And this is kind of research direction that we're setting up, we're building up at the moment. But I don't want this to be. We're doing this. I'm doing this because I'm interested in how humans ground their knowledge, how humans, for example, support claims of knowledge. I know that Mount Everest is that and that high because I've read a book about this, or because I wanted to be a mountaineer as a child. These kinds of how you offer support for knowledge claims, right? These kinds of mechanisms. I'm not saying that this will make open domain computer systems possible or ethically possible, but it might. It's an interesting research direction in any case. Okay, so with this, yeah. So I think for the foreseeable future, I think these are the better avenues here in green. And I think it's important to push back on attempts to do the stuff that's in red here. Okay, so with this, I've now for real reached the conclusions. Not going to read them out. Or am I going to read them out? I will read them out again. Okay, so the opposition, language processing and language use. And I think language use is not enough on the agenda of NLP of my field, but I'm curious to hear what do you say about this? I think there's a difference between how AI systems produce meaningful language and how people do. Importantly, I'm not saying that this is meaningless, what comes out of computers. I think the puzzle really rather is to explain how it is meaningful and how this is different from how something is missing, how this is deficient, right? And there are possible ways of addressing this. Yeah, I kind of felt compelled a little bit to put this here. So just 2 days ago, another of those models came out. I mean, the situation is crazy. You can't move without there being another large language model being released that can do clever things, apparently. So this is ChatGPT, a particular fine-tuning of this fairly well-known GPT-3 model, or successor of this at least. And this is set up so that you can chat with it. And what I find interesting here, and this is heavily fine-tuned to avoid any public relations disasters. So for very many utterances, it will try to kind of say, "Ooh, don't blame me. I'm just a model," right? And I think this is deeply weird. And I think what they're trying here is providing a service that's not quite clear what the service is. What's also interesting to see is that they succeeded. I think the community kind of likes this model, whereas another thing that was sort of last week, so 2 weeks ago thing, Galactica. So this ChatGPT is from OpenAI, Galactica is from Meta, and they completely bungled the release, right? They got enormous pushback because they framed it, well, they didn't even get this dissociation from the output of the model right. They framed this as if the model could write scientific articles. But at the same time, they said, okay, but what it writes, it may not actually be true. So use at your own risk. Yeah, this is a very weird place we are in. And I'm hoping that this is at least the beginnings of a framework to understand this state a little bit better. But I'll leave it at that and end here. And thank you and take questions.